Very good afternoon from Würzburg. My name is Sebastian Schreglmann. Dear Chair, dear colleagues, it's a pleasure to show some of our results from our recent publication. The majority of the work was done during my time at Queen Square. I have no conflict of interest to report, and this will be about non-invasive stimulation in phase for essential tremor. Starting with the aim and study design, with the study, we wanted to produce pilot data to see if non-invasive stimulation over the cerebellum in phase with a peripheral tremor can modulate tremor. And for this, we used this closed loop setup where we have an accelerometer over the tremulous limb that feeds into our custom-made endpoint-corrected Hilbert transform, which is an algorithm that allows the online real-time calculation of phase, which then steers the stimulation through surface electrodes over the cerebellar hemisphere. We used this quadruple replication randomized block design consisting of 6 different fixed phases and one block where we used stimulation at the same frequency as the peripheral tremor, but not phase locked, and a sham stimulation condition. And each block of 60 seconds consisted of 15 seconds baseline recording, 30 seconds of stimulation, and 50 seconds of post-stimulation recording. In the following panels, you can appreciate the effect on tremor amplitude over the 60 seconds of recordings, the black bar denoting the stimulation period. And the top panels show the summative results of all patients during non-phase locked, and the lower panels of phase locked stimulation. And as you can appreciate here from the original experiment, there's only significant decrease in tremor amplitude with phase locking denoted by these solid lines here. And in these 2 panels here, we looked at replicating our results. So we called 6 of the original 11 patients back 3 years after the first experiment. And the original experiment of these 6 is depicted in blue, and after 3 years in red. And again, you can appreciate that only during phase-locked stimulation, there's a significant decrease in tremor amplitude. We then, in the second step, wanted to see if we can make sense of this. So what actually happens during successful stimulation? We wanted to understand response. And for this, we compared recordings of successful stimulation of responders, and we looked at the accelerometer signal and compared what happened between baseline and during stimulation. And for this analysis, we used mass extraction of higher level features, so of all sorts of mathematical descriptions of these time series using the HCTSA algorithm. So we were able to extract over 7,000 features, and we then looked with a linear support vector machine to see which features were most accurate in predicting what happens. And through various steps, including this autocorrelation coefficient matrix here, we identified the main 9 features, and we could extract that a single feature that had the highest accuracy was the decrease in temporal coherence. And indeed, when we went back to the original recording data and looked in the frequency band of the tremor, we saw that there was a significant drop of temporal coherence in responders, whereas in the non-responders, there was an increase in temporal coherence. So in summary, I hope I could have shown you that the phase-locked cerebellar TACS can modulate tremor, and that the main mechanism of this is through disruption of its temporal coherence. With this, I'd like to thank you for your attention and my collaborators and funders. Thank you very much.
Thank you very much. Very interesting data, and certainly very welcome to have new approaches to treating essential tremor because we're so often limited by medication side effects.